All right, now what we're doing is getting into more complicated equations to solve. And let's see what happens here. This one's not too bad. I see that I have a secant squared and tangent, so just like the last lesson, I need to have the same trig function when I'm looking at this because one's a quadratic, so we have a quadratic form here. That's what we should be thinking. And what's the identity? Secant squared equals 1 plus tan squared. Or tan squared plus 1, it doesn't matter how you write it. So plus tangent x equals 5. Multiply all that stuff out. So we'll have 2 plus 2 tan squared. So I'll have 2 tan squared x plus tangent x. And since this is a 2 and we have the 5 is going to come over, we'll get minus 3. So now what do? Factor. Can you factor this without doing that substitution of let a equal tan x? It can be done, and it's up to you to decide whether or not this is the best way for you. I'm going to try to do it without it. The only way to get 2 tan squared is with 2 tan x and tangent x. Now we know this other side has to be a 1 and a 3 or a 3 and a 1. Where does it go? Well, when we multiply it out, we need a coefficient here of 1. So if I put a 3 on the outside, that would multiply to give me 6, and then this would only be 1. There's no way to get 1. So this 3 is going to have to be on the inside one. Now, is it positive or negative? Well, we want the result to be 1, so this will be 3 minus 2, so it's minus 1 plus 3. So we get tan x equals negative 3 halves, and tangent x equals 1. So when we take a look at our unit circle here, tan x equals 1 is there. We should know what those values are. That's pi over 4, first quadrant, and then 5 pi over 4. Again, that unit circle. So if you do know it exactly, give it exactly. On this other one, negative 3 halves, that's going to be a slope of negative 3 over 2, so a little bit steeper. There's 2 answers, and we need to find them. So we're going to take out and say x equals inverse tangent or arctangent of negative 3 over 2. So take out your calculator. Make sure you're in the proper mode. Let's hit a quick check. Yes, we're in radian. So we'll say arctangent of negative 3 divided by 2. And this gives us a negative number. So it is approximately negative 0.98 rounded to 2 decimal places. Now, remember, what's the period? So that what it gave us is this thing here. And what we need to do is we need to find it going all the way up. Well, how do you do that? Remember, what's the period of tangent? It is pi. So we can just say plus pi n, and on our calculator, you can just hit the plus button, and then second pi, and hit enter. And that gives us our 2.16 is approximately. And then all you have to do is hit enter one more time, and it adds that pi again, so we get 5.30. Remember, if you're going to go to 2 decimal places, you need to actually write both decimal places, even if it's 0. So we have 2 answers. 2 are approximate. 1 is exact. All right, let's take a look at the next one. This time we have 2 sine 2x. So this is kind of a combination of 2 things. I see a cosecant, which that's the same as 1 over sine. So I'll say minus 1 over sine of 2x equals 1. Now we have something on the bottom there. Let's clear everything out. So we'll multiply every single thing by sine 2x. So we'll get 2 sine squared of 2x minus 1 equals the sine of 2x. Move everything to one side. And factor. So this time, I'm going to say sine of 2x, and then sine of 2x. And we'll have a 1 and a 1. Actually, I forgot there's a 2 there, so I have to put a 2 there. And then I need to get multiplied out. It needs to be give me a negative, so this outside one will be negative and the inside will be positive. So sine 2x equals negative 1/2, and sine 2x equals 1. So if I look at this, negative 1/2 would be down here. So there are two parts to that, and then positive 1 would be up here. But remember here we have this sine 2x part, so our periods have been changed. We get 2x equals 7 pi over 6 plus 2 pi n. I'll have to squeeze it over here. 2x equals 11 pi over 6 plus 2 pi n. And then on this other side, 2x equals pi divided by 2 plus 2 pi n. So go ahead and multiply by 1 over 2 to everything. So we get x equals 7 pi over 12 plus pi n. Now that pi, since this is a denominator of 12, we can just put in a 12 over 12. And over here we'll get x equals 11 pi over 12 plus pi n, and that pi n would be 12 over 12 pi n. And on the last one we'll get pi over 4 plus pi n. But this time, instead of putting it over 12, I'll put it over 4. Now we can just list out all of our solutions. So we have 7 pi over 12, 19 pi over 12, and if I add another one, I'll be past my domain that I'm solving for. 11 pi over 12, 23 pi over 12, and then the last two solutions would be pi over 4 and 5 pi over 4. So there's quite a few solutions on this one. Not so apparent when we just look at that question. All right, the next one. We have 2 cotangent squared, so this one's going to start off similar to that first one, except it's going to be a little bit more complicated when we get down to the nitty-gritty of it. So we'll take that cotangent squared and do a substitution, and 1 plus cotangent squared is cosecant squared, so cosecant squared minus 1 will give us our cotangent squared, plus 3 cosecant equals 1. Multiply everything out, combined like terms, move everything to one side, so we have 2 cosecant squared x, and then this will give us minus 2 and minus 1, so that'll be a minus 3, and we have this 3 cosecant x. Now when we're looking at factoring this thing, we say, all right, what multiplies to give us negative 6 but adds to give us 3? Nothing. So what does that mean? Skip this problem. Let's go on to the next. Just kidding. All right. This is a quadratic form. We know how to solve every quadratic equation. The quadratic formula. Remember, x equals negative b plus or minus radical b squared minus 4ac, all divided by 2a. All right, so we have cosecant x equals, that's the variable we're solving for. That's a function we're solving for in this case. Negative 3, that's a coefficient of our b, or our x term, our a in this case, plus or minus square root of 9 minus 4 times 2 times negative 3, put that negative 3 in parentheses, and divided by 2 times 2. Simplify that, and we get negative 3 plus or minus, let's see, this would be 6 times 3 would be 24, or 8 times 3 is 24, and then 33 over 4. So now we have 2 possible solutions here. We have cosecant x equals, and let's just take out our calculator and we can find out what these are approximately. So parenthesis negative 3 plus r square root 33, close that, divide by 4. Now what I'm going to do right now, I'm going to use my memory. So let's hit STO alpha A, because just in case I need this for anything. this gives me approximately 0.68, or no, 0.69. Now I'm not going to use this number. I'm going to keep this whole number on my calculator. So that's one solution. Or cosecant x equals, do that again. Type it in here, and now do it as a minus, and I get negative 2.19. So there's two parts to this, and now we say 1 over sine is approximately equal to this, and the same thing on this side. Oh, I didn't store over here. Let's hit stow alpha b so we have that number. We do the reciprocal of this. Now, what's the reciprocal of 1 over 0.069? Let's see, that would be our 1 divided by, I put that in A. So that's about 1.46. And then on the other one, it would be 1 divided by B. So negative 0.46. When we look at our unit circle, 1.46 is up here. So what does that mean? This has no solution. And what about negative 0.46? That would be down here. There are two solutions here. They're definitely not unit circle values. So we're going to need to find these. Now, just so I have this, do I need to? Well, we have that on our screen, so we can just go inverse sine of answer. And so we get something that's pretty close to it, which makes sense because of that radian measure there. And we know that as we get closer to the 0, they're going to get closer and closer to each other. So we have x equals negative, approximately negative 0.48. Or what other value? Well, we have, that's this one down here. We're going to go all the way around. So we can either say pi plus this 0.48, or if I'm using this on my calculator, I'm going to have to say pi minus that negative. So I'll say pi minus this negative 0.48. So I can go pi minus answer. So I get 3.62. Now, is negative 0.48 a part of my answer? No, because it's not in my domain from 0 to 2 pi. So I need to get back this number there. And what I could just do is hit subtract pi, and that will give me my, will it give me? Not exactly. I'm just going to go through the whole process. 1 divided by B. I did the wrong one. B. And now I'm going to do inverse sine of that again. So if I would have stored this, then I could have skipped this step. Now I have this. Now how do I get the answer I want? I need the angle that's coterminal with that. So what I'm just going to do is add 2 pi to it. So just say plus 2 pi. And I get 5.81 approximately. So there are two solutions to this. 5.81 and 3.62. The next one. Tangent x equals x. How do I do that? We've done this type of problem several times now. When you see this, you have to realize that you cannot solve this by hand. You must solve this with your graphing calculator. So there's two ways you can do it. You could either say, and we went over these back in first semester, let y1 equal tangent x and y2 equal x. Or you could say tangent x minus x equals 0, so let y1 equal tangent x minus x, and then find the 0 of it. So let me do that one. I'm going to do the second one because there's less chance of an error for that, and the reason why is because if they intersected too high up, you wouldn't see it, whereas this is always going to bring it to the x-axis. So my window is going to be 0 to 2 pi, and I'm just going -5 to 5 because that's what was on the calculator. Now we have to realize that my calculator is lying to me. There is no asymptote. There's no line here because that's an asymptote. My calculator doesn't realize that because of the operating system I have. So what I need to do is find the zeros of it, and one of the zeros is going to be this right here. And does that make sense? Sure, because tangent of 0 is 0, and x equals 0, 0, so x equals 0 is one solution. Now I need to find this other one. Remember, we do second calc, and we would want to find the 0 in this case, so 2. And we want left bound, so I just want to be to the left. I'm just going to move it close to make the window smaller and make it so it's somewhere above. That would be fine. Move it so it's closer, hit enter, and we get about 4.49. Next one. There's a lot of serious stuff going on in this. So the next two problems show two very different approaches to these, but they're dealing with similar types of problems. When I see this, what I want to think is, since I only have the sine and cosine and there's nothing else added, subtracted to it, what I can do is divide everything by cosine. Now, does this violate the rule I gave you in the last lesson? I said never, ever, ever divide out a trig function. No, because I'm not dividing the cosines out. I'm moving it to the other side. And at this point, this becomes a pretty easy problem to solve. Slope of 3 is going to look something like this. We get two solutions. X equals the inverse tangent of 3. We can take out our calculator. Just type in inverse tangent 3, and we get, so x is approximately equal to 1.25. And what about the other solution? I just hit plus pi, and we get 4.39. So the reason why we can do that is there's nothing else added, subtracted to it, and we're not dividing out the cosine, we're just moving it to the other side. Now, when we look at this next one, this one's very different because of this 1. And so we can't just divide the cosine, because then we'll have 1 over cosine, and that's not good. So what can we do? What we're going to have to do here is we have to square both sides. Now you got to be careful whenever we square things. We're going to introduce extraneous solutions like we did back in chapter, I think it was chapter 1. So when we multiply this out, we'll have 1 minus 2 sine x plus sine squared equals 9 squared of x. Now it puts it into a form that we can deal with, because this one we have a quadratic form, but we have this cosine squared. We don't like having the cosine because we need all the same trig function, so we can change that to 1 minus sine squared. Multiply it out, and we'll have 9 minus 9 sine squared. Move everything to one side, so we'll have 10 sine squared x minus 2 sine x minus 8 equals 0. Now at this point you could divide everything by 2, so we'll get 5 sine squared minus sine minus 1. Now if you see that these two numbers can add up to give us the middle term, either the exact same or the opposite in sine, the plus or minus, then that tells us we should be able to factor this. Not we should, we can. So we'll have 5 sine x, and we have sine x. And we know we're going to put the 4 in there. So we'll have a 4 and a 1. So this will be a minus and a plus. So now we have sine x equals -4/5, and sine x equals 1. Look at our unit circle. We're down here for -4/5, and we're up here for 1. For the 1 part, that's easy. That's just pi over 2. For the negative 4/5 part, we're going to need to take out our calculator. I'll clear this, and we'll say inverse sine of 4 divided by 5, and we get x equals 0.93. Now let's store this. If you wanted to keep the things we stored before, what we could do is use a different letter, for example, alpha d. Now how do I get, oh, that was a negative. I didn't actually put that negative, did I? So I'm going to have to bring that back, and I'll go negative, and then I'll hit stow alpha d. So that's a negative. That gives us our first one. What we're going to have to do is add 2 pi to that to get its coterminal angle. And then we need to take pi minus that, or pi 93, in order to get the other one. So we'll say pi minus negative 0. And that, so I can hit pi minus answer, and that gives 0.7. Let's hit stow E on this one. Now I need to go back to this one in D, and I'm going to have to take that out and add 2 pi to it. Since I have that in there, I can just say D plus 2 pi, and I get 5.36. So now I have my 2 solutions. I need to stow that as well. I want just a little bit, so I'll put it under the one underneath I. And it's possible you could just label these if you want. So we have 3 solutions here, but the problem, since we squared it, we must check all of our answers. That is critical for this kind of problem when we square it. So what we need to do is x equals pi over 2. We're going to plug it into the original one. 1 minus the sine of pi over 2. Does this equal 3 times the cosine of pi over 2? Well, that one we can do without too much work. 1 minus 1 equals 3 times 0. Yes, that checks out. When we check the 5.36 one, we're going to have to say 1 minus the sine of 5.36. Does this equal 3 times the cosine of that? Well, this is all going to be done on the calculator in order to do this check. Now I put this in I, and it's also the number I just used. So I could use answer, or I could use I. 1 minus sine of alpha I gives me 1.8. 3 times the cosine of alpha I gives me, I think I said 3.8, it's 1.8, sorry. 1.8, that checks out. Let's check that last one, 4.07. And so we can do that same thing, 1 minus the sine, but we put the 4.07 into E. And that gives us 1.8. And then we go the 3 of E, and that gives us negative 1.8, so no. So our answers in this case would just be pi over 2 and 5.36. And that is all. Finally, huh?